Hello Internet, today we have the EVGA 3090 that came in for repair not long ago. Card is sealed, but I have reason to believe that that seal is fake because we have the quality OK sticker here. And that quality OK means only one thing, that the quality of the repair that the EVGA RMA service had performed is not okay. Now let's do the math and see how many times this card had been in the RMA. Alright, let's get a razor blade and start counting. So there's one layer, 2 layer, and 3 layer. 3 layers of EVGA sticker. That means this EVGA card had been RMA'd at least 3 times, which means it is probably 3 times as bad as it can be. But who cares? Let's go ahead and take this thing apart. Before I do that, let me show you what I found is wrong with this thing. I think the red light or something is what the customer had said. So we got this multimeter here. Check for beep. Alright, so do we have a beep here? No beep. What about here? A beep and a steady rise, as the graph suggests, which means fuse is there and the 12-volt circuit is slowly charging because the multimeter is supplying voltage to the probe. That's how it measures for resistance. If we check the next 12-volt rail, which is separate from the rest of them, we see nearly identical graph. See here, the resistance starts low and then it starts to drop, and as the resistance decreases with the capacitors getting charged more and more and more. So, but in here we read absolutely nothing. We can also check 12 volt here. It's going to be a little different result because there's a whole lot less going on this 12 volt rail, and 3.3, nothing there. So let's go ahead and take this thing apart. I'm guessing we have a blown driver MOSFET and a fuse as usual, and I'm guessing if this one has a UP9512R, if I'm not mistaken, somebody pointed that out, then we might run into that one pesky capacitor that causes the blowout on these cards, as well as pretty much any 3080, 3090. I'm not exactly sure what the manufacturing date has to be in order for that to be true. Kind of wonder if any of you out there that are well informed regarding this problem, is it the date or just the board revision that are affected by this bug or oversight in the manufacturing process? So please do let us know so that we can all tell whether or not we're about to have a huge blowout without taking the card apart. So slowly split this thing in half. Hopefully it wasn't split in half aggressively before, which would create problem. There we go. Yep, that's an RMA for you. A very typical mess that I see all the time with EVGA RMA. It's just a pesky putty here that I absolutely hate. And they got that thermal paste all over. It's that phase changing one. Yeah, how they get it all across like that, I have no idea. Like everywhere. I mean, look at it. They just flood the core with it. And then, you know, because they don't care. They're gone, so who cares? No more EVGA. I am glad. Don't come back. Your RMAs suck. Anyway, who cares? Let's go and get rid of this. I will clean that up later. Get rid of the pads. Nasty EVGA pad. I'm sure they're good. I just don't like it because it's EVGA. I don't know. I think EVGA is overrated. A lot of people overrate EVGAs regardless of their constant power monitoring system failures. Sometimes the chip that controls your fans will go bad, and just a lot of problems, especially with the power related stuff. So, which I'm actually expecting to have some power related issues today. A lot of times, I'd say 90% of the time, if not whole 99 of them, when the one of the driver MOSFETs gets blown, problems with power management appear during testing. We're gonna have to see if that's gonna be the case today. All right, we need a thermal camera. We might actually be able to spot the blown driver MOSFET. It's usually in this area here without the thermal camera. So let's go look under a microscope. Visually identify it. Usually there's a sign of a blowout on the side somewhere, and it's usually the one like right here or something. Either this one or this one. It's almost never none of these, but it looks like, look at this, it looks like it actually might be this guy, folks. It looks like it might be this guy. Yeah, it might be this guy. See this ball on the side, and then this ball here. So That's not necessarily true though, but it could be. Hard to say. So, but it is almost always this. And if that's almost always this, then my question is, who's driving it? 9511R? That is correct. The 9511R is driving this phase. Where are you? This is the NVDD. And I don't think the capacitor is here. Yeah, the capacitor is not here. So I don't know. I guess it just keeps blowing regardless of what controller's on the board. Because that questionable capacitor is supposed to be here, but it's not. See here, there are no weird capacitors soldered anywhere. So all of these are necessary. And I don't know. Yeah. I guess it just failed by itself. So let's inject some voltage, confirm that that is indeed the faulty driver MOSFET. Hopefully we can see it on the thermal counter, but if we can't, we're just going to go ahead and assume that that's the one. So we're going to have to inject after the fuse because fuse is blown. Right, so we need to inject after the fuse. We're not pulling any amperage whatsoever. There we go. Bad contact. And let's focus on these driver MOSFET and confirm that it is its neighbor. Okay, it's actually this one. So it's not this one. It's the one underneath it. And what happens sometimes on these EVGAs is because of the way they wire these driver MOSFETs, some of them are actually linked together, and what happens is you may have one faulty driver MOSFET, and then the other one gets blown, but not because of itself, but because of its neighbor. So the neighbor went crazy, and then the adjacent driver MOSFET that's linked to that crazy neighbor just happened to die. So you end up replacing the MOSFET that died, and then later on it either dies again, or the crazy MOSFET that was bad at the very beginning finally died. Bottom line is, when that happens, it's kind of hard to tell, but if you have an oscilloscope, which according to Northridge Fix you do not need, you can check for signals, and that will tell you whether or not the driver MOSFETs are both operating correctly or not, and if they are, then you're okay. But a lot of times what I see is people, some kind of repair shop, they usually replace the wrong one, or not so much the wrong one, but the one that failed as a consequences of the other driver MOSFET failure, instead of getting them both fixed. But it is what it is. We're gonna have to deal with it. So I don't like either one of these, to be honest. So we can see 016A, 016A, so, and then we got 016A. So it looks like, I'm not a doctor here though, but it looks like these are all originals. And then we got like 1, 2, and 3 driver MOSFETs here that are constantly blowing out. And I think the reason, because they're not original, see, the markings don't really match, and I'm thinking that it was this guy or this guy, most likely this guy, was causing the trouble. So, and it finally gave up. But I don't know, just a speculation based on what I've seen. How I explained earlier that they are kind of linked together. So I'm not gonna this guy either. I'm gonna go ahead and replace this because these solder balls that are sticking out on the side, and we're going to replace this one and this one, and we might keep that one on there. We'll see if the signal is looking great and nothing's overheating, or at least not running hotter than normal than its neighbor, then we should be okay. So let's get that done and see what happens. There's our fuse. It looks crispy. Let's apply some Black Horse stuff on it. I like Black Horse flux. It cleans easy, so I don't have to spend too much time cleaning stuff, especially inside cracks or between the pins and whatnot. Very enjoyable experience with that flux. Not advertising, just sharing. Let's get this thing out. There we go. And plug in a new one, or try. There we go. Woo! It wants to fly. A little bit more Black Horse stuff, horse manure. There we go. That looks good. Now let's switch over to the driver MOSFETs, which are here. And let's go and remove both of these driver MOSFETs just to be sure. Yep, this one came out easy, and this one doesn't want to come out. Yeah, this one was definitely soldered by 2 different people. I think this one has already let its solder on there. Hard to say, but it came out easily, so I guess it already had let its solder on there. There we go. Alright. Hopefully I'm doing it right. Let's double check. Yep, I'm doing it right. Okay. Okay, I think this is looking good. Let's go and wipe this out as much as we can. Let it cool down and see if it works. Alright, driver MOSFET replaced. Let's check for resistances. Got myself a mega chip lifter. It's a huge suction motor here. Yeah, 24 volt, I think. It's gonna lift any chip off the board. It'll probably lift the board with the chip. Who cares? Okay, alright, so no more short here, no more short here, and no more short basically, and your fuses are good. Was this reading half? Nope, that's reading good. What else? 1.8, 5 volt sometimes gets short after one of the driver MOSFETs could potentially short circuit the 5 volt rail. That should be it. Let's power it on. I'm still guessing we're gonna have problems with the power monitoring IC, as it usually is. It's just too common with these cards, but who knows, maybe we'll get lucky today. Maybe because it's Sunday, we're gonna have a special blessing, and we're not gonna have issues with the power monitoring system. Who knows? Alright, so let's go and limit this to 4 amps, power it on, see what it looks like. I'm gonna fire on the oscilloscope so I can verify. Yeah, it looks very good. Looks very even. See? Very interesting. Almost too good to be true. So, I'm gonna have to verify this real quick. Actually, well, I could use this, but it's just a pain in the butt to connect the probes to because it's using these little mini connectors. What a shame. Why'd they ever do that? That's just the dumbest thing ever. All these Chinese manufacturers, they always come up with some stupid idea that ruins everything. So this one looks beautiful. This one looks beautiful, 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 beautiful. Every single face looks absolutely, every single face that could potentially be affected. But otherwise, on the thermal camera, it looked gorgeous. I have no reason to check for anything else. All right, let's go ahead, jump into Windows, install drivers, and we're going to check the stats for the power and all that good stuff. Make sure that it's giving us expected values. Otherwise, we're gonna have to probably replace the power monitoring chip at the front of the board, which is the front. It's the front of the board that usually fails for whatever reason. I don't know. It's this little guy here, that little black dude. Yep, it's that black dude. Maybe one day they're gonna start making white chips, so we'll be calling them the white dude. All right, who cares? All right, they all bleed the same anyway. What is it that I want? HDMI cable goes here. Put some standoffs here, so we have some support. One more here, and let's go into Windows. Actually, I gotta wipe the core so it's nice and clean before we apply the cheapest thermal paste in the world, called HY510. It's a $5 a gallon, I think. So I just buy them a lot because I use them for like testing and whatnot. Alright, so I'm going to put some weights on here to help with paste spread. It's going to give us some sort of a protection from overheating. Not necessarily the best, but it's not going to be the worst. So I think the card is going to post. Yep, there we go. Okay, driver loaded. Let's go into, we're gonna run some heaven here just to see if the clock goes up so we don't overheat. The clock is at the 210 whatever, doing nothing. So voltages look okay, so we want to check for voltages. Pin 1, 2, 3 supposed to be the same voltages, same power, more or less. PCI Express voltage and the wattage is going to be very low compared to the rest of them when it's under load, obviously. And let's go and run this, see what the clock is doing. So we're maxing out the clock as soon as we're loading the gaming engine. Temperatures are still low, waiting for the TDP to change. And yep, we're gonna overheat at some point, but at the very least we can see that we are reporting more or less correct values. Sometimes it's hard to say just by running this kind of test. I still need to run a whole test under 100% load because sometimes you get stuck at like 75% TDP or something like that, which is not something that I can do right now without fully assembling this thing. But I don't know, hopefully this is one of those that's not going to have this problem. And we might just get away with replacing 2 driver MOSFETs and the fuse. What I'm going to do next is put it back together, apply some fresh pads on there, run some tests, and if everything's okay, then have a great day. And if not, I will continue on with power monitoring, circuit replacement or diagnostic or whatever. And we'll see you later. Thank you for your support, your comment, and for your subscription. Goodbye.